Hi guys. A lot of people were asking online about Apple's serial communication baud rates and how to calculate or brute force baud rates, so I decided to make this video. A shout out to James Duffy who actually raised the question, and this recording is pretty much for everybody asking the same question. So let's talk about baud rate before we even begin. Okay, baud rate is the maximum number of times that a signal is changing between 1 and 0 in 1 second. This definition is based on J.M.E. Baudit. And I took this definition from size.com. Okay, so speaking about bounds, baud rates is the bits per second. That means we need to calculate how many times the protocol changes its state from 1 to 0 in times scale of 1 second. Okay, normal signaling on the iDevices is calculated with time scale of microseconds. So we'll have to divide all of our calculation with 1 million, okay, because we have 1 million microseconds in 1 second. Okay, so before we begin, we will need to have several things set aside for this experiment. The first thing is any kind of serial cable. I'm using the Bonobo cable or Alex cable or DCSD cable, whoever has it, okay? And you want to have a breakout board. I have this one. It's excellent and I have a lot of flexibility in connectivity and disconnectivity from the different pins, okay? And of course, a logic analyzer. I'm using the CLA 16 Pro, which is excellent for everything. Now, this is how you connect it, okay? Connect it to the channels that you want to sniff, and you start the recording, okay? And the connection is very easy. Usually, iDevices have TX on pin 6 and RX on pin 7, okay? So connect the pin out, connect the logic analyzer, start recording, connect the breakboard to your iDevice, and then stop the recording after like 3 seconds. It's enough. Okay, so I took the liberty of recording several different iDevices communication to help calculate the baud rate on this video. Okay, so let's jump through it. The first one is AirPod first generation. Okay, so you can see I have here some data going on channel 7, and what I did is I'm adding async serial to this channel, okay, give it a predefined bit rate of 9600, and together we're going to calculate the true baud rate of this communication, okay. So giving it the 9600, we see a lot of arrows, but it's not enough, okay. So what we do, we zoom in, okay, zoom in, and you see how the protocol changes its state from 1 to 0 and 1 to 0 and 1 to 0. And we want to have this time measured in order to tell the async serial analyzer what is the correct baud rate or bit rate for the specific communication, okay. So looking at the values, we see 4.3 and 4.32 and 4.3 and 4.32 and 4.304 and 4.32. Now we don't have to have be very accurate. We just need to have some kind of an average. So what I'm going to do, I'm going to add some markers and count signals 1, 2, 3, 4, 5, 6. Okay, 6 signals, and 6 signals out 225.88. So I'm going to take that numbers and I'm going to divide it. I'm going to do 25.888 and divide it by, as we said, 6 signals. Okay, so we have 4.31 average for bit rate in microseconds. Okay, so we want to take that and convert it into seconds. Baud rate is defined in seconds. Okay, bits per seconds. So we want to take this number and divide it by 1 million. Okay, so let's do that. Let's do division by 1 million. And we see that the current baud rate for this communication is 231,767. So let's take that value and redefine our serial communication with 231,767. And let's see what happens. Okay? All of a sudden, we have a lot of data that we didn't have before because now they are translated correctly. We see we don't have any errors. Now, the beauty of Logic Pro 16 and the Logic 2 beta software is that we could dump the data directly to console. So I click on the console, and as you can see, we have acknowledgeable information going in the communication. This is B235 EVT version 1.7.7 bootloader banner from the AirPods first generation. Okay, so just to summarize, this is roughly 231,767. We can round it up to 800, which is usually the units. And you can see we have even a clearer output, okay? So this is the first example. Now let's do another example. Okay, so this is the first generation. This is the AirPods second generation, the one with the knot on the case for charging. Okay, so we have here on channel 7 another communication. We go in, zoom in, and we look at the time, the least amount of change in time. Here we have the same calculation. Okay, we take 1, 2, 3, 4, 5, 6. These are 6 signals. Okay, transition from 1 to 0. Okay, and sorry, that's a typo there. 26.092 for 6. Okay, so let's take the average. Okay, 26.092 divided by 6. This is not right. Let's start from the beginning. Okay, 26.092 divided by 6. So this is 4.348 microseconds. Okay, we want to convert it into seconds, so we do take the reciprocal and multiply it by million. So we'll take the reciprocal and we multiply it by 1 million. Okay, so we get really close to 230,000 bits per second. Okay, let's take this number and feed it to the analyzer setting. So we're going to change the setting and feed it with 2299.55. And let's look at the data. Okay, you can see that we have a really cleaner output. Case hardware EVT, firmware version 2.0.2 application. And as I said before, if we convert it to a modulo of 200, okay, in this case, this is roughly around 230,000 bits per second, okay? So let's round it up and see what happens. Okay, you can see we have a cleaner output for this communication. Okay, so this is AirPods 2. Let's jump and to the next example. This is the AirPods Pro communication, and we do the same thing. We zoom in. Okay, let's zoom in. Come on. Okay. And we have here 1.09 microsecond. Let's take one that they are closely aligned. Let's see. Let's take these. Okay, that's promising. Okay, we have several signals aligned, 1, 2, and 3, one after another. So we know that these are 3 signals. So let's take those averages. So again, I'm opening up a time marker 1, 2, 3 for 3 signals, 3 transitions, and those 3 transitions are 3.24. Okay, so let's take the average of 3.24 divided by 3. This is 1.08. Now let's take the reciprocal of it and time it with 1 million. And we get 92,592.5, okay? And we can copy this value and give it to the async serial settings. And we can see that it translated into data. Okay, so let's look at the output. And you can see the output is cleaner. Okay, you can see see the commands that have been sent at the view message and the output of the banner from the AirPods Pro case. Okay, then again, we can always modulo the baud rate to 200. Okay, and this is roughly 926,000. Let's do that and see if we get a cleaner output. And you can see we get a cleaner output. So the AirPods Pro are in fact communicating serial over 926,000 bits per second. Okay, good. Let's go for the last example. Oh no, we have 2 more examples. The Apple Remote 4. Okay, so this is the Apple Remote for the Apple TV 4th generation. Okay, you can see we have a lot of communication going on channel 7. And let's take again the average of several signals. So we count signals 1, 2, 3, 4, 5, 6. Okay, those are 6 signals, 6 transitions of bits from 1 to 0, and those 6 bits were transmitted over the period of 51.824. Okay, so let's take the average of this. Okay, let's do 51.824 divided by 6 bits. We get to 8.637 per bit, and these bits are in microseconds, right? So we need to convert it to seconds. So again, we take the reciprocal and multiply that by 1 million. 1 million microseconds in 1 second, and we get 115,776. If we copy that value and feed it to the serial analyzer, we could see that the data has been translated. And if we look at the console output, we could see that we have DX prompt and main radio touch radio. All of the variables are decoded. Okay. Then again, we want to modify the value to be modulus of 200. So we could say that this is roughly 800. So we could see 11.5800. And we have an even cleaner output. Okay. And the last example we have is something new I just got last week. This is Lightning to Ethernet USB and USB-C adapter. And let's see what happens when it's connected. So this is a recording of the Lightning splitter communication. And as you can see, we have two channels talking over serial, and data is broken. So let's just match channel. Okay, this is channel 6. Let's give it channel blue. And this is channel 7. Let's make it purple. Okay, so let's start with channel 7 as we did before. We zoom in. We look at bit transition from 1 to 0. Okay, let's take this sequence of bits. This is 1, 2, 3, 4, 5 signals. Okay, we got 5 signals, and 5 signals were 263.228 microseconds. Okay, so let's divide that by 5. 263.228 divided by 5. We'll take the reciprocal and multiply that by 1 million. And we get roughly, this is 18,994. That's roughly 19,000. We'll check that out. Let's feed that to the analyzer settings, okay, for channel 7. And see what happens. Okay, we see we have now numbers 0, 2, 5, 4, etc. Going on channel 7. This is a purple output. If we look at the output in the console, we see we have some junk. Okay, not very decodable binary data. Okay, let's do the same thing for channel 6. Okay, and channel 6, we take another average of measurements. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is enough. Okay, this is 10 signals, and this is 513.7096. So let's take that number and divide it by 10, and we have, so it's 51.3796, and take the reciprocal of it and multiply it by 1 million. Okay, and we got 19,462 for channel 6 baud rate. Okay, so let's feed that to a channel 6 communication, and let's see what we see now. Okay, we see that we have framing errors, I think. No, let's see. Okay, we see that we have actual data going out on that channel. You see we have Apple iPod accessory and something that looks like Apple certificate. So this is a certificate that's being sent over the wire from the accessory to actual to the iPhone. Okay, so let's look at the values, if you can modify them into 200 moduli and get an updated better value. So this is 19,462. Let's do this 19 and 400 and see if we get a better data out of it. So we see we have Apple accessory. We're good in that output. Let's see the purple. Channel 7. Okay, so this is roughly 19,000. Okay, so let's change it to 19,000 and see if we have any update. No, this is still junk, so it's probably a different protocol, a different implementation that needs to be translated. Okay, so this is everything that we have on baud rates and iDevices, and why you don't need to brute force the baud rate. You just need to understand the definition and do the small math. Okay, until next time, keep hacking.